Okay, so here's the video for calculating the confidence interval for a population mean given sample data. So in class we were given the sample mean and the sample standard deviation. In this case we're going to calculate it. So in your assignment you're given how many data points? 30 data points. So they're on your sheet. So go ahead and enter them in one column. Put data as the column header, and then you have the 39 data point or 30 data points ending with 68.2. Now, so what we need is the sample mean, the sample standard deviation. So let's just put those numbers up here. So we'll put mean here, and we'll put standard, and let's actually put sample mean, sample mean, sample, and we'll just put SD for standard deviation. SD. Okay. So the sample mean is equals average, left parenthesis, cells A2 through A31. And we get 69.12. Make sure I'm down to cell A31. Oops, went too far. Yeah, so it goes to 31. You can see right there. Okay, so that's good. Okay, and then we need the sample standard deviation. STDEV A2 colon A31, right parenthesis. So that's my standard deviation. Now, what we can then do is do the standard deviation of sample means, and stretch that so it's wide enough to get the whole thing. So what we do there is we take the sample standard deviation, which is C2, and we divide, so slash, and then we do the square root, SQURT, of the number of data points, which is 30. So we get 1.1875. So that was step 1, step 2, step 3. The next thing is to find the critical, T-critical. So let's just write that in there. There's probably an Excel function that does that, but for right now we're going to use the table. And the key thing is we need to know the number of degrees of freedom. So let's actually double click on that cell. We're just going to put left parentheses DF equals 29 because we have 30 data points. And we said the problem says 90% confidence interval. Okay, so that's what it's going to be based on. So let's see, we need to go to the internet. So let's add a tab, do Google, and put in critical T-value table. And the first one is this PDF file. You open that up, it should look familiar. And so the left column is the number of degrees of freedom, and we have 29. So if you come down here, you see 29. And then you see the confidence level over here, so 50, 60, 70, 80, 90. So we have a 90% confidence interval. Let's go up that column until you get to the row with 29. So here's 29. Come over here to 90. The intersection of those two is 1.699. So we'll put in 1.699. Now, actually, this is something we should have done. We have 30 data points, so the requirements are that if the number of data points is greater than 30, the original distribution doesn't have to be normal. But as part of this assignment, we'll do a histogram and look at the normality of it. So you have to do that. You do that by doing a histogram. So we're actually going to do a few things down here. We're going to find the minimum value and the maximum value. So we'll do the formula. So we'll come over here. So if we put equals min left parenthesis A2 colon A31, that'll give the minimum value in that list. And if we do E equals max A2 colon A31 right parenthesis, you get the maximum. So the difference is equal to 81.8 minus 58.5, 23. So now we need to do a histogram, we need to do the bins. So this is our bins list. So we're going to start with a number less than 58. And we're going to do increments of something till we get to above 81.8. So you could do 5s, but that's not that many bins, and so I'm going to go to 6. So I think 6. So if you start at 60, and then go 64, 68, 72, 76, 80, 84. So this first bin will do numbers less than 60. This one will do between these two values. This one will be between these two values. They'll also do 84 greater. There'll be an extra row associated with more. But for the bins here, we don't put in a range. We just put in a single number. So it's below 60 because there's no number previous to this. This is the first one on the list. And then that's the second bin. So we should have 1, 2, 3, 4, 5, 6, 7 bins. We may have a very small amount because we're almost 60 there. Okay, so we have the data, we have the bins. We'll put the output over here. So let's go to add-ons, Excel Miner Toolpak, start. We'll go down to histogram. So we need to put our input range in. So one way of doing that, besides doing it manually, is we can highlight the cells. In this case, there's not that many cells, so you highlight the cells and you click in the box. Okay. Next, we need the bin range. So let's go up to the top here. So you highlight the bin range. Once you have highlighted, click in the box where the bin range is. We'll put the output right here. F1, click there, it goes F1. Because the input range did not include the header, we don't need to click labels. And we want a chart output so we can see what it looks like. And that's it. You say OK. And we close it. So this is our frequency distribution. And if we look over to the graph, so we go to the right, here it is. So, it's not a perfect bell curve, but it does have the ends being low and the middle being higher. So we'll assume that the population is a standard, or has a normal distribution. So what that does is allows us to use the process we've done so far. Okay, so the last thing is, we need to figure out what the margin of error is. And the margin of error is equal to the critical t-score times the standard deviation of the sample means. So that's our margin of error. So we'll say lower, what do we want to call that? Lower number of interval, higher number of interval. So that these two numbers will define our confidence interval. So the confidence interval, lower number is the mean, 69.12. So and what I'm doing here is I'm clicking in here instead of writing in C2. Plus, minus the margin of error. So that's it. And then the upper part of the interval is going to be equal to the mean plus the margin of error. And what we can say now, if we kind of make this smaller so I can look at the numbers. And bring up my sheet so I can write it out. Actually, I'm not sure if I'm going to be able to. So let's just go down here. Margin of error. So it's from 69.1 to 67.1 to 71.1. So what we can say our 90% confidence interval for the population mean is, and I've already think it was 67.1 to 70. What do we get? 71.1. And what that means is that if we use this procedure, that 90% of the time the population mean will be within the interval specified. So we don't know if this works or not, but we were saying it's pretty sure that the mean. We're not really sure, but we're pretty sure that the population mean is between these two values.